Welcome back. This is the third lesson recording for IM2, March 10, 2021. Okay, so now we are on card number 11. We need to find the roots for y is equal to 3 times x minus 2 all squared. What is the equation to solve? Well, the equation to solve is we're going to set this to be equal to 0, right? So it's going to be 3 times x minus 2 all squared is equal to 0. And hopefully you know how to do this. This is going to be x, so 3 times x minus 2 all squared is equal to 0. The question is not asking you to do it, but I'm just going to show you how to do it. Again, the easiest method is because we have something squared is equal to some number, 0 is still a number, so I am going to use square rooting. I'm going to divide both sides by 3. I know that that cancels out. 0 divided by 3 is still 0. So that means x minus 2 all squared is equal to 0. Then I take a square root of both sides, as I've done before, and that, don't forget the plus or minus, and the square root and square root cancels out, and you're left with x minus 2 is equal to square root of 0 is 0. Can you have a plus or minus versions of 0? No. So it's just going to be 0. That means I only have one solution. I have bring negative 2 to the other side. That becomes x is equal to 2. So x is equal to 2 is my only solution, which means my root for this function is also x is equal to 2. Okay, this time the question is asking you to find the roots. Okay, what is the equation to solve? The equation to solve is y is equal to x squared minus 2x plus 6. Remember, to find the roots, you need to find the equation that gives the output to be 0. So the equation to solve is equal to 0, and then now finding the solution, or finding the roots, is going to be using this. And what is the best method to solve for this? Well, let's look for two numbers. Well, let's try factoring. What are the two numbers that multiplies to 6 that might add to negative 2? Okay, 2 times 3 would not add to negative 2. 1 times 6 would not add to negative 2. So that means that the only thing I can do is use quadratic formula. So in this case, a is equal to 1, b is equal to negative 2, and then c is equal to 6. So x is equal to negative b, negative of negative 2, plus or minus square root of b squared, that's negative 2 all squared, minus 4 times a is 1 times 6 all over 2 times 1. And that is going to be negative of negative 2 is positive 2, plus or minus square root of negative 2 all squared is negative 2 times negative 2, so that's positive 4, minus 4 times 6 is 24. All over 2, which is same as 2 plus or minus 4 minus 24, that is negative 24, negative 20. I'm not going to make the same mistake again. So it's going to be 2 plus or minus square root of negative 20 over 2. I can break the fraction as 2 over 2, and then plus or minus square root of negative 20 over 2, like so. And 2 divided by 2 is just 1, so plus or minus, what is square root of negative 20? I can break that up as 4 times 5 times negative 1 all over 2. So that simplifies to 1 plus or minus 2 root 5 I have my square root of negative 1 there, divided by 2. Now I should be able to see that 2 is being multiplied to square root of 5, but then divided. So I can cancel this out. 2 divided by 2 is my giant 1. So this simplifies to 1 plus or minus root 5i. That means one solution, one complex solution is 1 plus 5 root I. and the other solution is 1, x is equal to 1 minus 5 root 5i. Okay, so I have two complex solutions. I do not have any real solution. I have two complex solutions here. Okay, so here are the graph of the three functions you found roots for. Okay, so this is the very first one where we walked you through all the steps. This is the second one, and this is the third one. Look at the graphs. What do you notice? Okay, so with the first one where we had two roots, two real roots, they're the two x-intercepts. When we had the second one, we only had one root that was positive 2, and that's where the graph actually just touches. So that means the graph actually crosses the x-axis just once. It just touches at that point. Whereas the one with no real solution, it's a floating parabola. It never crosses the x-axis because it does not have any real root, but it does have complex roots. Okay, so if it has complex roots only, if it does not have any real roots, it's never going to be crossing the x-axis. And I explain again here in the slides. So again, the first problem, it had two real roots. The second problem, it had one real root, and the third problem, it had three complex roots. So real roots are the x-intercepts. So whenever you see a real root, they are going to be your x-intercept. However, the complex roots have no x-intercept. They are the floating parabola. Alright, so that's it for today. So I would like you to add table of content in your notebook. Quadratic equation with complex solutions and roots of quadratic functions. And I would also like you to finish the Desmos activity because it is going to be graded. Okay, thank you for listening. Have a great day.